desk, Ladyada.
Hey everybody, and welcome back to my desk. Okay, well last week we talked about some chips. This week I made stuff with those chips. Hopefully folks who are in Florida are staying dry. It's gotten kind of wet here in Brooklyn as well. So we're staying in doing some electronics. Okay, so first up, last week we covered, let's go to the computer. We talked about the BQ25185, which I thought was kind of like a cool standalone LiPo or the lithium ferric phosphate. I really need to look at how I pronounce that. Charger with adjustable rate, thermistor, status, pins, etc. So to get started, I just designed a really quick USB-C board that uses this chip. So USB-C over here, this is the chip in the middle. I will say one thing, I mean, I don't mind if it's a QFN, but it is 0.4 millimeter pitch. So you just gotta make sure your PCB design is nice and solid if you're gonna be using this part. And the battery and the load, and then DC in, and battery and load breakout, and then also breakouts for all of the different the thermistor, voltage set, current set, stat 1, stat 2, and CE. So, you know, we actually have a, was it the MCP73833? You know, this is one of our first charger, part number 259. So kind of mimicking this a little bit, but trying to do like a better, like a, you know, more, and it's a little smaller too, and of course it's USB-C. So, that's coming out shortly. I ordered the PCBs, and then if you want to change the voltage or current, you can cut this and then solder on new resistors to ground. Maybe I should put a ground pad over here somewhere, but I don't know. You can maybe use one of these ground pads. Okay, cool. So that's the BQ25185 breakout, and then I also did. I was looking at this chip because I wanted to revise this board, which was a USB-C LiPo to 3-volt output. So I swapped it out, and you can see it's actually like I had a little bit more space because I don't have to have that load sharing the power path output because this handles power path for you. So this one I don't have all the you know GPIO things brought out. I basically set this to 1 amp by default, and then there's on the back a jumper, which if you cut will make it 500 milliamps. I figured like those are the two options people want the most. And this buck gives you a 3.3 volt regulated output, and this is not actually 5 volts. I should put a little twiddly because this is the output from the load to the power path load, which is guaranteed to be no more than 4.5 volts, but it can be as low as 3 volts if the LiPo battery is dead. But if USB is plugged in, it will give you USB. So, you know, whatever. This gives you maybe like about, you know, when USB is plugged in, 2 amps of 5 volts, and maybe half an amp of 3.3 volts. I don't remember what the capability of the buck converter is. And then LiPo backup. So you can take this, you know, you can unplug it, hot swaps out, and you can take it on the go. So I did that. Another thing is, pardon me, YouTube, if you search for, what was it, Ladyada DVI HSTX, and can I sort by, hold on, because I don't have my overhead hooked up. So we did a video for this adapter board, which you can watch it. This is when I first designed it, and this is when I actually got it working. So with this, it's not going to play audio, obviously, because I don't have it hooked up. I got the PCBs for the HSTX peripheral on the RP2350 to DVI output, which means that you can really easily with this, like, it's only be a couple bucks. This converter board, it takes the signals, shifts it around, blah, 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 connects all the I2T and does the whatever, and gives you a DVI output that you can then connect to an HDMI monitor. The RP2350 has like 520 K of RAM. So if you're like, in theory, if you did 640, whoa, hold on, 640 by 480, you can basically do 1 byte, so 8-bit color, because if you can't do 2 bytes color, because that would give you need 640K of RAM. So you can do 8-bit color. So I think you can either do palletized 8-bit or you can do 232, which or 323, sorry, which will give you, you know, it's not like amazing, but it'll give you like some basic color. Or you can do what we're doing here, which is, you can see it's a little chunky. It's 320 by 240, and then we pixel double it. So you get like, each pixel is actually 4 pixels. And so you get 320 by 240, which is only 74K, and then 2 bytes per, so about 150K, which leaves you like 330 whatever K of 360 whatever K of RAM left over for CircuitPython. So you could easily do a 320 by 240 display, pixel doubled, and still have plenty of RAM left over for like Wi-Fi, Bluetooth when the Pico 2W shows up, or if you want to like have something else. Oh wait, I went blurry. Do you know I went blurry? Whatever's cool.
Oh yeah.
I look better. Smooths up my skin.
See what happened here. What could have happened?
I don't know. It's no big deal.
No. How long was it going?
I don't know, like 30 seconds.
Okay. Let me see what happened.
This is live, by the way.
Yeah. Weird.
Whatever, it's cool. I mean, like,
Okay.
more people end up. Oh, now fine. Thank you.
Okay.
Maybe I reached and autofocused. Okay, so that's that. So I did the DVI output. Then I did a couple other small designs. So I'm still like digging through my pile of everything I designed in 2021, 22 that didn't get made. So I have the LPS28, and I chatted about this board on INMPI in 2021, like late 21, and I actually designed a board then as like a breakout, because it's actually a really nice absolute pressure sensor with a port from TI, but the problem is that the pricing was like 3 times what it should have been. Like the chip was supposed to be like $4 a piece, and it was like $20 or like $15 minimum, and I was like, I don't think people are willing to spend that much money. So if you go to DigiKey now and you look, it's a much more reasonable, you know, of course individually it's $7, but once you get to like, you know, 100 pieces at least, it's down to $3 to $4, which is much more reasonable. So I ordered some sensors and I ordered some PCBs, so we'll get this board out soon. And then what was the last thing I did? Oh, okay. So the last thing I did is I have a product I'm working on, which is a secret, that requires 2 UARTs. It has like a programming UART and a separate interface UART. And so I wanted to make a board for it, but I didn't want to have 2 USB to serial converter chips, just to save space, because I wanted it to be a very compact design. So I found this breakout board, USB serial. So I've stopped the the CP2104, sorry, 2102. And this is, you know, 1 USB-C, and it gives you like all the pins and everything, and FTI output. It gives you 1 serial port. But I wanted 2 serial ports, and I found the CP2105. And the price is actually like really good. Not much more than just the single CP102. and Cypress is really, Silicon Labs is very good about having drivers available for all operating systems and getting them like it. I've had very good experiences with their chips. So, you know, comparatively. So I decided, let's make a breakout for this so you can see the design. It's very similar to the CP2102 or 2104, except it's got 2 UART outputs. Only thing is, you don't get all the GPIO. So like with the CP2102 or 04, you would get like all 8 UART pins, like your RX, TX, DCD, DTR, RTS, CTD, like ring. You get all 8 pins, and you also get like 2 GPIO for LEDs, and you also get like the suspend and the reset. With this, the pins are shared. So if you did want to have indicator LEDs, you don't get to use like DTR because one of the LEDs is on the DTR pin. And for a lot of times when people are using dual UART, UART for programming chips like the ESP32 or 8266 and friends, you want to use the DTR and RTS pins for like reset and boot mode toggle. Like it's a little bit of a hack. You can use those as like plain GPIO by setting the flow control status in Python or C or whatever, and then that puts into bootloader mode, and then you can program it over the RxD and TXD. But you can't do that if you want the LEDs. So what I did on the design, because I like the LEDs, right? So which is a problem. I was like, I don't want to lose those LEDs. I really like having a little bit of status. Is I broke out the 2 UARTs, RX and TX, and RTS and CTS, which are like the basic, just like data sending and flow control. And then I brought out DTR because, again, DTR is used a lot with Espressif chips and also with Arduino chips to get it into bootloader mode. And then I put one LED on the DSR. I tend not to use the DSR or DCD. I've rarely seen people use those I/O pins. And so I thought those were worth sacrificing to get an LED. So there's one LED indicator. I'll see if I can program it to be like for any signal, but it's probably just for like receiving data. Still, it's better than nothing. Like it's better than no LED at all. And then this DCD pin gets lost because I wanted to use the VPP. This is the programming voltage input. If you put a capacitor on this, it means that you can use USB to program the chip status to activate these LEDs. So this pin also gets lost, which means you get ring, DTR, and then TX, RX, RTS, CTS, and then also there's also like one random like GPIO2, which you can use. I've used these GPIO pins by using the Scilabs libraries in Linux. You send it like an HID command. Sorry, not an HID command, a control channel command to like endpoint 0, and you can toggle the GPIO. It's like a little dorky, but like, I don't know, maybe there's some purpose for it. And this is what I came up with. So chip in the middle, 28 pin, couple passives. I managed to use 0603 and 0805 for everything. And then UART2 is over here, and UART1 is over here. And then I have just the RX and TX pins, because I didn't want to make it FTDI compatible. I wanted to have it be like, you could plug it in top down and get like the GPIO plus 5 volts. So this is CP2105. So I sent out these PCBs as well. How are we doing on time?
You're at 14 minutes.
Great, let's do the great search.
Where in the world is that part I need? The great search with DigiKey.
The Great Search brought to you by DigiKey and Adafruit. This is the time of the week when Ladyada user power of engineering to help you, yes, you find the things you want on digikey.com. Ladyada, what is the Great Search of the week this week?
Okay, so this week we actually had a request. Somebody emailed and said, I really liked that thin RG174 coax that you guys used to stock. We'd stock 10 feet for like, $5. It was a good deal, or $6. I want more of it. So yeah, we used to stock this. I personally love this stuff. I actually remember in school using this for a bunch of different projects because ultra thin coax. It's the same thickness as like 16 gauge wire, but it actually has 2 conductors. It has a shielding output and a center stranded core. And it's very flexible, very durable, weatherproofy. Love the shielding. I was using it for like passing RF signals around or like capacitive touch signals or something where I needed a ground wire along with it. Used also. I'll tell you what it's often used for. We have these like little thin RPSMA cables with very skinny coaxes, and here's another one, very thin coax to handle RF signals. So definitely great if you're doing RF signals. I was using it for wearables because I needed to pass high-speed signals around with the ground wire, and I wanted to be ultra flexible and like very durable and abrasion resistant. So but we don't stock it anymore because, to be honest, we didn't sell very much. So let's go to DigiKey, and we can search and find it. So specifically, now of course I lost the page. The specific thickness they wanted was 1.2 millimeter. Think about it, it's quite thin. So let's see, coax cables, and I don't think we want an assembly, I think we just want the raw cable. And then we have a CP. We want it to be active, so we can still buy it, because obviously we don't want it to be discontinued. One thing to watch for is conductor strands. If you're passing like current to, wow, look, this is 140 gauge, 105 strands. This doesn't tell you the thickness because these are the individual inner strands. Like, it's basically how flexible it is on the inside. Also, ditto wire gauge doesn't really tell you much. What we want to do is find the thickness, jacket insulation diameter. Yes, this is the outer diameter. You can see it gets quite thin, but let's see, what can we get that's like 1.4 millimeters or thinner? Because I think the person who emailed, they said like 1.2 millimeters, but it seemed like they were a little flexible on how thick it could be. Okay, so the good news is that this basically like cuts out almost all of the options. Another question is what the impedance is. I'm gonna guess 50 ohms, but to be honest, I don't know. Sometimes you need 75 or 100, so I'm not going to select it. And then I'm going to exclude Marketplace, although I don't think, yeah. I'll tell you one thing you don't want to select is in stock, because a lot of times for cables and wires, DigiKey will cut the length you want from a much larger spool, like on demand. And so you don't necessarily want in stock, because it might be like the spool is in stock, but the individual cut wire isn't, and like you just want to see like what's available. I've just noticed. And let's just say we do want RoHS compliant. Okay. So let's see what's available. Okay, so micro coax, these are looking really cool. I like this clear look from Alpha. Another one. So the only thing to watch for is you can get like, normally you have to pay a lot to get a gigantic spool, so like $350, not unusual. But you'll see stuff like this, Twin Max. So from Molex, this is coaxial. Wow, only like 1.04 millimeter diameter, super thin, for 88 cents a foot. This is sold in feet, so like a really good deal. And then different, 100 ohm, 100 ohm. I'm assuming they have a 50 ohm here somewhere. Let's do it from pricing. Okay, so looks like, the cheapest you'll get is these ultra skinny 34 gauge 100 ohm Twin X. And then they have another 100 ohm, 84 ohm. Now you're getting into spools. So this is a 10-foot spool, so it's actually like about the same price. And this is 10 feet of 50 ohms. Spiral. Wow, ultra thin, 0.5 millimeters. That's like so skinny. Kind of scary. Let's say they only want 50 ohms, just so we can pare this down. And then for length, let's say we want only the cut foot type, or 10 feet, so 3 meters. Okay, some good options. So, you know, the only thing is I didn't know what size they actually wanted, because they mentioned like, you know, 1.2 millimeters, but I don't know if that was a specific width or not. So I'm going to assume that they actually want that specific width. So if so, first off, there's a lot of other options. If you want a little thicker, this is available. But this one's in stock and it's 50 ohms. And it's a little bit thinner, but maybe, I don't know, I'm going to assume they actually want this specific thickness. And this is 1 foot. Well, it's 1 foot for $10. It's kind of expensive. Well, let's go back here. I'm going to change my mind. Because it's a continuous spool. And this is a spool of 10 feet. Oh, this is by meter. Oh, that's so bad, actually. $20 per meter. Well, it's still expensive. I think this is 10 feet. $3 a foot. What's this one? Interesting, as it gets thinner, it gets a little cheaper. Let's actually go with this one. Because at least you're going to get, 10 feet. So it's $3 a foot. It's not bad. And it's the thickness that they're looking for. Because it could be that they want to carry some current. 1.12 millimeters. And it's 50 ohms. So I think this is my pick. From Alpha Wire. Available in 10-foot spools.
And that's a great charge.
Thanks, everybody.
Where in the world is that part I need? The great search with DigiKey.
All right, well, we're still going. We're still cranking. We are going to see everybody throughout the week. We have a ton of new products, surprises, and more. Stay tuned.
Bye, everybody.
Bye-bye.